In this video, we're going to continue looking at our sequence of 5 important lemmas. We're now going to be proving lemma 3. In the two previous videos, we've proven these two lemmas. The first one says that if A triangled with itself is equal to A, then A is actually the right identity element promised by axiom 3 in our group axioms. Lemma 2 says right inverses are actually two-sided inverses. In other words, if we have A triangle with A hat is equal to ER, then we also know that A hat triangled with A is equal to ER. In this particular video, we're going to prove lemma 3. And lemma 3 states that the right identity element in axiom 3 is actually a two-sided identity element. And again, before proving this, I want to talk about what this really means in symbols. So what we're trying to do is we're trying to show that the right identity is a two-sided identity. In other words, what we're basically doing is we're going to be saying, let's let ER be the right identity in a group G that's promised by axiom 3. So what we know is that for all A's inside G, A triangled with ER is equal to A. We need to prove that ER triangled with A is equal to A for all A's inside our group. And our strategy is going to be to start with the left-hand side of this equation and manipulate it until we get to the right-hand side, starting with an arbitrary element inside our group. So let's go to the next page so that we can do that. So let's let A be any element inside G. So A is arbitrary. And we want to look at this. We know that there exists an A hat inside G such that A triangled with A hat is equal to ER. And by lemma 2, we also know that this is A hat triangled with A. That is lemma 2. This is axiom 4. And so what I want to do is I want to look at this. Let's look at ER triangled with A. Now, ER triangled with A can be rewritten as, well, let's see, ER can be rewritten as either this expression or this expression, and I'm going to choose this first expression. So we're going to say that ER is equal to A triangled with A hat. And then, of course, we have triangled with A. And this is by axiom 4. It's the definition of A hat, the definition of right inverse. But now I can reassociate. I can put those parentheses wherever I want to, and I'm going to change the parentheses to where I've got A triangled with A hat triangled with A. This is by associativity or axiom 2. But now let's look at what's sitting in here. What's sitting in here is this, and by lemma 2, we know that that is equal to ER. So lemma 2 kicks in, and we can rewrite this as A triangled with ER by lemma 2. And of course, A triangled with ER is known to be A by the definition of a right identity. In other words, this is axiom 3. ER is a right identity. And so what we now have is that ER triangled with A is also equal to A. This formally completes the proof. But I do again want to think about, what does this actually mean? In other words, what have we actually shown here? We have shown that if ER is the right identity from axiom 3, so we know that A triangled with ER is equal to A for all elements inside the group, then we happen to know ER triangled with A is also equal to A, and because the choice of A was arbitrary, this is true for all elements inside my group. But now think about what that means. So ER is now a two-sided identity element. In other words, the right identity in axiom 3 is a two-sided identity because it's both a right and a left-sided identity element. It acts on the right side and it acts on the left side as an identity element. That completes this video.